Look at this example here. Zoom in quickly. So example 1, okay, it's a product. So it's a product. We don't have to worry about multiplying by the reciprocal. That's nice. This looks a little bit messy. Looks like I might want to start canceling. I cannot cancel right away because I do not have factors. Only factors I have are 3 and x right here. In the bottom right. 3x are multiplied by each other, so these are already factored. But nothing else is factored. So let's go through this process of factoring. First fraction, what do I take out? In the numerator, what do I take out? Somebody besides Maury answered a couple questions already? 3x. Thank you. 3x. What does that leave me behind with, Sebastian?
1 minus x.
Very good. Don't forget the 1. Don't forget the 1. The placeholder of a 1 is very, very important in this topic. Even when we cancel factors, to leave a 1 behind is very important as well. Denominator. What multiplies to -5 and adds up to +4? What does that factor into?
+5 and -1.
Sounds good to me. Second fraction. The numerator is the only thing I have to worry about. The denominator is done already.
X plus 4. Yeah, x minus 4. And then x plus 5.
And Alex, did you notice that x plus 5 is here?
Yes.
That might have kind of goaded you into doing that, right? Now, don't fall into the misconception that it's always going to cancel, but you're right there. Good. What do you pick up on here? They're opposites, aren't they? So what do they reduce to leave behind? What did we just say a little while ago?
-1.
Yeah, -1. Very good. So let's cancel these two, but not forget, -1 gets left behind. You don't put a -1 on the top and bottom, though, because then they would just cancel, right? It's not logical. So when you cancel these right here and here, leave a -1 behind in one of the spots. It is not in both spots, or else it just becomes -1 over -1, which is just 1. And that's clearly not 1. You need a -1 behind in one of the spots, top or bottom. How about what else can cancel? Or question, go ahead.
Why is -1 left behind?
Because if I look at this, this is really 1 minus x over x minus 1. That's what I have here, right? Think about numbers. Pick a number for x.
2.
Put a 2 in for x. What do you get? -1 on the top over 1 on the bottom, which is -1. No matter what numbers you use, if you switch the order of subtraction and you have a fraction where the top is the opposite order of the bottom, it will always reduce to -1. Okay? It's not useful to prove it every time. So I'm assuming that you know now because I've written it. But the way to prove it would be to switch the order of these, and that would cause you have to factor out a -1. And therefore you'd be left with 1 over -1. Okay? So we leave behind a -1 in one spot, leave behind a +1 in the other spot. What else? What else do I cancel? So that's vertically canceling, right? We did vertical cancellation. Vertical's done. Regina?
X plus 5 and 3x.
Yeah. Cross cancel those and cross cancel those. A lot of cross canceling going on here, right? What's left behind in all those spots? The number 1. Now, it's not that important, obviously, if it's left behind and it's in the denominator, because anything over 1 is itself. But if you leave a 1 behind in the numerator, it's a big deal, right? The answer of 1 over something is different than that just something itself. So it's important to recognize that you have a 1 left behind in these spots. Yeah, in the bottom it doesn't matter as much, but I'm telling you now, there are so many students who do this. Ready? They do this. They say x over x times x plus 4. And when you cancel, the x's are gone. And they write the answer as x plus 4. It's not x plus 4. What's the answer? Yeah, 1 over x plus 4. We've got to leave a 1 behind here and a 1 behind here. Okay? And it's really important for the numerator. Not really important for the denominator, though, right? You can see that? The denominator, a 1, doesn't matter. But a 1 by itself in the numerator absolutely matters. So after all of this, we've got all 1s in the bottom, right? So the bottom doesn't matter. Dividing anything by 1 doesn't matter. So who cares about the bottom? Up top, though, 1 times 1 is still 1 times -1, and then x minus 4. So it's really just -1 times x minus 4. Okay? Or how could I write it? I could write it as negative x plus 4 or 4 minus x. Any way I want to write it. I could just distribute the negative term. So you can write it this way. Or instead, again, you could also write it this way. Any of those three answers are acceptable. Okay? Again, distribute the negative 1 to both terms makes it that. Negative x plus 4 is 4 plus negative x. Same thing. Good? It's easy, right? Good. Shake your head yes if it is. If it's not, I'm just really that boring, I guess, huh? All right. 2 more examples. Why don't you guys try example 2 on your own? Example 2 is very simple. It's just division. So I would start this problem by right away multiplying by the reciprocal and then go through it. Try this one on your own, say you do. But again, practice, please. Practice. Make sure that you leave behind the ones where they're needed. Make sure you're factoring properly. This is a great section to practice your factoring skills. For those that struggle with factoring, I told you it wasn't going to go away. This is not the last time you're going to see factoring. You'll see it more this year, and you'll see a lot of it in your junior and senior year class. Not as much in sophomore year, actually. Junior year and senior year, you do a ton of factoring. It's one of the fundamental skills that you're learning. And if you're quick enough, you can flip and factor at the same time. I'm not showing that, but you can. Okay, I'm just showing the flip, the reciprocal here. But if you want it at the same step, factor as well, by all means, you should. So 7x can't be factored, but everything else can. Everything else can. And always start with GCF, and then go on to regular factoring techniques. I did the GCFs already. Check your work with that part.
Actually, are you allowed to cancel under the unpaid denominators?
Sure.
Like, can you cancel these out?
No, you can't. And recognize that this is division, isn't it? So let's change this to multiplication and invert the fraction. And then they will actually reduce, right? So that's what I actually started with. I started by writing multiplication and just flip that. And then I went on to factor. You can do it all in one step, but don't forget to flip it, okay?
So,
Well, let's see. It cancels. So I think cancels. 7 is times x, right? So those are factors. 2 is times x, so those are both factors. So what's in the top and the bottom? You're overlooking the obvious. It's like literally glaring at you from the screen, like screaming, "Cancel me, cancel me!"
okay.
Yeah. Right now, do you realize how obvious it is?
Yeah.
Yeah. The answer is a number, by the way. The answer does not have x in it. I'll give you the answer when we get to the answer. It does not have x in it. Exactly. But remember, it's multiplication, so that's just cross canceling. So and if you don't see how the x is canceled at the end, just multiply across. You end up with 7x over 2x, and then it's obvious, right, that they cancel?
I think I got it.
You did get it. I know you got it. We get 7 over 2, 7 halves. Okay? To show it real quick, x minus 5, x minus 6, cancel, cancel. Let's use another color, cancel, cancel. Now, some of you at this point, because 2 of you did ask me this, so I want to talk about it. See that the 7 times x is here, and this 2 times this x look like they're separate. So it was a question of whether you can cancel or not. You can, and if you forget though, just look at what you would end up with. You would end up with, in the numerator, simply 7x, in the denominator 2x, and then that becomes 7 over 2. All right? Again, if you multiply it across, this is 7x times 1, and this is 2 times x, becoming 7 halves. There's one more to go. There's one more. That's why I said this was an easy, quick lesson. The last one, though, let's point out something that's going on here. What do you recognize? Part of it is multiplication. Part of it is division. When you think about division, it's multiplication by the reciprocal. So be careful here in this problem. You're only going to invert one of these fractions, not two of them. Okay, you're only inverting one of the fractions. It's really tough to factor, by the way, so I would start by factoring whatever's easier, and then figure out the other ones afterward. So here's what I'm going to do to be lazy, and that's what I would do if I were you, okay? I don't want to rewrite the entire thing, so just cross it off, make it a time symbol, and just invert that third fraction. Again, you're only multiplying by the reciprocal. So this is the multiplying, and this here is the reciprocal. You're not inverting these fractions at all. They stay alone. It's only what comes after the division sign that gets inverted, and then the division sign becomes a multiplication sign. Okay? So switch it, then flip it. And then we're going to factoring. And it looks like we're going to have binomials for all of these. So we have a lot to fill in. There are some that are super easy. Fill them in first. Okay, so that's what I would start with. You should be able to factor these as quickly as I did just there. I mean, I give you a little bit of time, and these are not difficult numbers. The other ones are much more difficult, much. So if I'm you, I would start with this and start canceling right away. Right? We can cross cancel anything. So let's try and cross cancel. X plus 4, boom, gone. X minus 4, also cancel, gone. X plus 2, also cancel, gone. Why did I just do that? Let's talk about problem solving techniques. Why did I just do all those cancellations first? What do you think, Regina?
So that you just have to multiply two binomials, and it's not as messy.
Good. It's not as messy. We don't have to multiply two binomials. I agree. There's something else to it. Food. Something else to it.
Is it because then you kind of know what your other ones are going to be?
Yes. Remember that whole idea of like, well, you know what? I need to factor this though, don't I? There's a good chance that x minus 7 might appear here. And look, that's a 14. 7 times 2 is 4. You see what I'm saying? So by canceling what's already repeated, you see what's left. And there's a good chance now that you'll get x minus 7 up here. That'll cancel. You might not, but give it a thought, you know? And I know already that this has to be this. It has to be that. Nothing else am I going to use for 3x squared. It's got to be 3x and x. It's got to start that way. So if I try minus 7, that might work. Let's try it. Just because you know what? There's a minus 7 here. That's the reason I'm going to try it. So let's put a minus 7 right here. Now, when I do that, what does that make this have to become? How can I get 14 as a negative when I multiply by negative 7? What number does it have to be? What is it? Positive 2 has to go here. 2 times negative 7 is negative 14. Well, does the middle term work out, though? Can somebody check the middle term? Does it work out? Ready? 3x squared, outer, negative 21, inner, 4. Negative 21 and 4 is negative 21 and 2 is negative 19. So they do check out. So these factors are correct. And I didn't even touch AC method. You see what I'm saying now? It's a much faster way than AC method. And what else does that help me with? Cancel out the x minus 7s. Okay, those are gone now. And if there's 3x plus 2 here, there might be a 3x plus 2 down here. I don't know. This one's really tough. This could be 3x times 4x, or it could be 6x times 2x. So this is a really messy factoring at the end of it. So we can't assume that it's naturally going to cancel. We could try it out first, though. So let's try it and see. If we put 3x plus 2 here, it means this has to be a 4x. Again, 3x times 4x is 12x squared. Well, 2 times what gives me 6? 3, right? So this has to be a 3. Let's see if that works out. So again, I'm not even using AC method at all here. 2 times 3 is 6, that works. 3 times 4 is 12x squared, that works. 3x times 3 is 9x. 4x times 2 is 8x. 9x and 8x is 17x. Oh, look at that. 17x. So I didn't touch AC method. And now I can cancel further 3x plus 2 with 3x plus 2. Those are gone. So it leaves me behind with x plus 5 over 4x plus 3. Okay, a lot of the time you can use the problem itself to help you to find the factors without having to use AC method or any other more extensive. It's really AC method that helps you with, right? It gets rid of using it. I mean, you could do AC method for this. Did anybody actually do it and get the factors? You can do it for sure. It just might take you a little more time. It might take you a solid minute and a half to write out all that stuff. Whereas here, once I factor the easy stuff, I kind of can see what else is coming along the way. Okay, and I did not look at my answer, just so you know. I know the answers here, so you might think, oh, it's right here, so he knows what it is. But as I did them, I worked through it with you and saw the repetitive nature. Oh, this was here, so it probably is here. And then it worked out, and the others worked out.
Why did the example before the x is able to cancel out and
Because it was 2x, or 7x over 2x. 7 times x, what does that make them both? These are times. They're both what?
factors?
What do you have here? Do you have 5 times x over 4 times x? You have 5 plus x. So this is a term. This is a term. These are neither factors. You can only cancel when you have factors. Okay?
And the factors only one is if we've been known one, right? So we can't use 3 of them. And if there's 1, like so say if there's x5 and it's x5.
If it was in every single term, yes. Because then you would just take the GCF out of top and bottom. And those again. Hey, homework tonight, please. Do I see you guys tomorrow? Day 2, yeah. Homework tonight, yeah. So homework tonight, 5-5, please. Come by after school with questions or project help. So yes, it's in all the terms. So if you have 5x plus 5 over 20x plus 15, they're all in 5. And everything you also have 5. Because technically you're taking 5 on the top and you're left. Is that what you're asking? Yeah. Do you have your actual testing or not? Hang on, sir. So you never knew your midterm grade? Oh, you saw it in your report card yesterday. Okay. But you want to see the breakdown for it, yeah. So if it's not in there, it means that I just put it in the wrong folder, unfortunately. So I have the hard copy though upstairs. I take pictures of my phone, and that's how I upload them to Drive. So right now, I delete the pictures afterwards. I don't have it on my phone. Actually, I could check. I might. Let's see. I might have it actually. Let me see. Maybe it's on my phone. Let's see. I think I do actually. Here. Let's see. Oh, there you go. So there's your breakdown. I'll put it in your folder in a second. But 34 to 40 on the multiple choice because you have 3 wrong on multiple choice. 12 out of 15, and then 37 out of 45. But then there was a number that points back to the problem. Okay, I'll put this in your Drive folder. If you want to see your test, come by after school. Okay? Or tomorrow morning.